So at Belkin, just a quick overview. We're helping our customers bridge strategy and execution for their digital transformation goals. So we have a team of, our lead team of experts, some of those, Mike Werkheiser, myself, we have Will Smith, Cassie Adams in the back that here traveled with us today. So we have a large team of experts with 5+ years of model-based enterprise implementation. We represent and go to attend a lot of industry standards, so lots of industry standards engagement with ASME, DMSC, DEDMEG. We have a lot of certifications, but we're tool agnostic, so we support all the major CAD platforms and a lot of the third-party software tools that are out there. So Belkin is a well-established engineering consulting firm, been around for 65 years, has a global presence, 10,000 employees. And we support a lot of various different domains like aerospace, defense, space, and automotive. So yeah, we have a booth, so come check us out if you haven't already. So we're going to dive into some terminology, and I'll go even deeper in terminology here in a few slides. But we think about characteristic, okay? This would be the dimension, the tolerance that we're authoring, whether it's in a 2D drawing or within our model-based definition. Okay, but we ultimately want to establish a characteristic tag, and this would be the graphical tag that's either that's both human and machine readable, that is applied to our characteristic, our requirement. And then we have our bill of characteristics, which would be the compiling all of my characteristic, all of my product characteristic tags into a single bill of characteristics, and Daniel Campbell walked us through the bill of characteristics within QIF. And then we have characteristic accountability, right? Ensuring that all of our characteristic requirements have been met with traceability through the verification process and with verification results. And so we're going to walk this process in detailed steps throughout the presentation. So this slide looks familiar, right? So this is the QIF overview. I'm not going to talk much about this, but we are going to be leveraging QIF, that's Quality Information Framework. It was developed by the DMSC, and it's also an ISO standard. So it is available free. I don't know if Daniel mentioned this, but you can go to QIFstandards.org to download this standard right now. All right, so I highly encourage you to do that. So let's talk about characteristic accountability. Today, many of you are probably doing this within 2D drawings, okay? And if you pay attention to the bar at the top, when we think about an OEM versus a supplier, right? At an OEM, you're creating drawings today. You're authoring product definition across very specific views on multiple sheets, right? Lots of product definition. You're assigning 2D specifications to those individual requirements, whether it's through 2D notes or other methods of assigning additional specifications that need to be characterized. You're releasing and issuing this product definition within your own internal OEM, but then once it gets to the supplier, or we'll call that the producer domain within manufacturing or your supply chain, they're going to characterize this data. So they're going to characterize the 2D drawing manually, okay, assigning characteristics. And they're also going to characterize the 2D specifications manually. And they're going to compile this into some type of a spreadsheet, into some type of a database. But our complete, we're calling complete bill of characteristics, is happening at the end of the process. All right, and that's going to be key as we move forward. So there's gaps in the digital thread. And so some of these gaps are, when we think about a single source of truth, that the characterization isn't unique, right? So, or it is unique to, I guess, across each supplier. So if we have multiple suppliers involved, and I had some conversations with individuals here at this conference, where you are characterizing for a single part across multiple suppliers, but those characteristics are not persistent across those suppliers, and that is an issue. This process is really time consuming, right? It's manual, right? And it's also error prone. Okay, so from a quality perspective, it's error prone. from a traceability, right, it's a very manual effort, and it's hard to align these characteristics to inspection results. And interoperability, bill of characteristics does not support machine workflows. Okay, so this is a very, very manual process. All right, so let's talk about model-based definition. Sorry, I'll go back if you want to get a picture of that. Yeah. There you go, pause. So when we think about model-based definition, and this was a slide that we've seen it at 3D CIC, we saw it here, Jennifer, you talked about the elements of model-based definition. And when we break model-based definition down, this was actually something that was brought up at 3D CIC, and this was something that we also share the same opinion, that the elements of model-based definition consist of geometry, right? That makes sense. But we also have annotations, all the requirements that we're authoring across our presentation states. That's another element of model-based definition. And then we have attributes and parameters. But more importantly, we have characterization. So we see that as a fifth element that we can author within our model-based definition that brings a lot of value for that issue we just talked about, which is persistent IDs across multiple suppliers, persistent characterization across revisions. And we'll deep dive more into that here in a little bit. So if you look at the top, you'll notice that the bar has changed a little bit. We're going to do a bit more work up front in our process to characterize our data before sending it off within the producer domain. So we need to characterize, or we need to create our model-based definition. So we're going to author all of our product requirements, okay, within our model-based definition. We're going to still assign 2D specifications, but we're going to characterize our model-based definition up front. Okay, so we have our parent characteristic or our product characteristic tags that we'll talk about here in a little bit. And then we're going to characterize our 2D specifications. And we're going to merge all of this to create a single bill of characteristics that is comprised of both 2D requirements and 3D requirements. And then we're going to leverage QIF, the Quality Information Framework, that format that Daniel just talked about, to leverage within our downstream workflows. And then we're going to consume that into the supply chain. All right, so now we're shifting our characterization left in the process, up front in engineering. And so this is enabling the digital thread for all of those shortcomings that we just talked about in the 2D workflow, right? The characterization is now authored within the engineering definition. When we talk about speed, right, automation. So we are now doing this through a machine-readable format, but we're also able to characterize our product definition up front using third-party tools. So software, right, when we think about quality, we're now removing the human in a good way, right? So it's no longer error-prone. So this is a software-integrated automated process. So we have unique characteristic IDs, so it's now persistent throughout all of our revisions, throughout all of our suppliers. And we have data interoperability and consistency throughout. So let's take a look, now that we've framed up what characteristics look like in a model-based environment, let's take a look at a characteristic accountability workflow. And we'll be using this diagram as we realize all of these process steps for consumption. So starting off with our 3D model-based definition. So we're going to showcase how to characterize your data upfront in model-based definition, and then we'll leverage QIF MBD to use within our quality workflows. We'll showcase how to characterize 2D specifications using OCR technology, and then unify our 3D and our 2D requirements into a single bill of characteristics. Right? And then we'll leverage that bill of characteristics within our downstream metrology software to perform measurement planning and to automate inspection routines, and then even generate first article inspection reports automatically, and then bring it all together to showcase the as manufactured, the as inspected back to the as designed, comparing those measurement results back to the as designed using QIF. So we'll start off with our 3D model-based definition. And before we get into that workflow, I want to talk a little bit about the emerging standard, the model-based characteristic standard that was developed by the DMSC. And this is the same standard that's being developed, same standards organization that's developing the QIF standard that Daniel Campbell just got done talking about. And in June of last year, this was submitted to the ANSI Standards Organization to be approved as an ANSI standard. And that should be soon. So this is a quite lengthy document, right? It deep dives into nomenclature, definition, symbology for model-based characteristics. And it identifies specific types and categories for characteristics and their optional augmentations. So this is a product characteristic tag, right? The elongated hexagon. And its optional augmentations are being draped on either side of it. And we have augmentations like criticality classification, product requirement association, and even a verification plan if one is desired. So there are two primary product characteristic tags that I want to talk to you guys about. Hey, let there be light. So this is a screenshot of the QIF derivative, and where we've authored product definition. This is showing a single view of one of our presentation states. So we've got a light show. And I have lots of product definition that I've authored. And you'll notice that I have visual, so this is the graphical product characteristic tags that you see here. So these are our product characteristic tags. And these are also known, and maybe, don't hate me, parent tags, right? And I've assigned, we have product characteristic tags. These happen to be assigned to a pattern of 4 holes. And because I'm associated to a pattern of 4 holes, I also have instance tags. Okay, so here are my product characteristic instance tags, or the children of my parent characteristic tags. And you'll notice that it's reusing, for my instance tags, I'm reusing the parent ID, and I'm also giving it an instance ID of 0.1. And I have a feature of size dimension and a position tolerance. And you'll notice that each hole respectively, in all of its parent IDs, have the same instance ID for each hole respectively, which is awesome. When we look at a bill of characteristics, so this is a screenshot of NVIDIA's software for visualizing the bill of characteristics. And just to deep dive a little bit into what the information that is within a bill of characteristics. And as we generate QIF, and we generate and we visualize our bill of characteristics, one thing I want to note here is that we have a universally unique identifier that's being associated for each QIF file. And this is more at a top level. As I generate QIF across revisions and even versions, we need to ensure that QIF files can stand on their own. Okay? Within the bill of characteristics, here is a look at the pattern of 4 holes that I just got done discussing in the previous slide. So the bill of characteristics is giving me some information. I have my characteristic IDs, both for parent and instance IDs, and even the presentation state that they originated from, which is really nice. And this is the information that's been extracted from our native CAD. We also have our measurement feature or measurement object. So Daniel talked a lot about the features that are being generated within the QIF file. And this is going to play a really big role as we import this data into our downstream metrology. And the type of features that we have here, you'll notice that I have cylinders, and that's key. And a lot of what I get here is dependent on the way we author our product definition up front in our native MBD. Now, I'm not going to go down that rabbit hole, but I could author this in such a way that for my feature of size dimension, my associated features, my semantic references, are cylinders. And that plays a big role that if I only have circles, right, I would get a circle here as my measurement object or measurement feature. And that's what I would get when I import this into my downstream metrology. I'm also getting information like product and manufacturing information, so that's the PMI, and then also access to visualize my datum reference frame. Now, this doesn't have to be just a tool that's used for quality and manufacturing to view this information. I think it's really important that we start to shift this up front in engineering to be leveraged as a tool to understand how is my product definition being decomposed, not only from a human perspective, but from a machine readability perspective prior to release. A lot of times we're not looking at this data until after it's been released. And if there's an issue, what do? Oops. Right? Or we go back and we spend a lot of money to go and fix it. So let's talk about generating a QIF file. So you'll notice that to generate QIF, I'm going to start off in my native CAD. And I'm showcasing Siemens NX, but this is a CAD agnostic workflow. So insert your CAD system here. Okay, so it doesn't have to be Siemens NX. And I'm authoring product definition across multiple presentation states. And I'm even authoring characteristics in this scenario. And those are represented by these red balloons. Okay, so I'm characterizing my product definition. And there are third-party tools out there to help you characterize your product definition up front in your native CAD. And that's where you get those benefits of persistent IDs across revisions. Many of you, probably all of you, are using 3D viewables today. So now your downstream audience can visualize those characteristics in your 3D viewable in addition to seeing those as they're being consumed within your downstream process. So as we export to QIF, and in this scenario we're using MBD Connect for NX. MBD Connect exists for all major CAD systems. But we're going to be harvesting information from our native CAD system. So we're harvesting geometry, all of the PMI across all of our presentation states, and even our characterization in this scenario. Where QIF, as they assign characteristics, it's going to honor the characteristics that were already assigned within my native CAD to generate my bill of characteristics. But this bill of characteristics only represents the requirements that are in my model-based definition, right? So my general notes and all the PMI that I've authored across all my presentation states. It doesn't include 2D specifications. So that'll come next. I do want to note, right, there's a lot of benefits of authoring characteristics here up front, leveraging the DMSC standard, right, the model-based characteristics standard. But you can also have a lot of value by assigning characteristics within your QIF workflow. The one big thing to note is that the source of truth for characteristics in this workflow is up here in my native CAD. But it's completely acceptable for your source of truth for characteristics to, as you generate those, when you export QIF, to exist right here, right? So there's still a lot of value. So we need to validate our QIF prior to consuming our QIF within our downstream workflow. Okay, so we need to validate it to ensure that it is fit for use. All right, let's talk about 2D characterization. Let's bring 2D specs and characterize that 2D data and bring that to the table. So in this scenario, I'm taking the QIF file that I just generated from my native model-based definition. I'm importing this into NVIDIA, and you'll notice that I have a set of general notes. And one of these notes calls out a 2D specification, and that happens to be an ISO standard. All right, so I need to go and pull that 2D specification, right, that ISO standard. I'm going to import it into NVIDIA's software. I'm going to characterize all the requirements that I have to comply with. And then using the built-in OCR technology, I'm going to harvest this text, and I'm going to insert it into my bill of characteristics. All right, so now I'm merging my 2D and my 3D requirements into a single, complete bill of characteristics. All right, and I'm doing this up front in the process, which is even more important. So a very, very powerful workflow. So now we have a complete bill of characteristics, and I'm going to import this into my downstream metrology software. So in this scenario, starting off with NVIDIA. I'm using that complete bill of characteristics using QIF, and I'm going to import this into PolyWorks Inspector. But there are a lot of other metrology softwares out there, and actually many of them are here today. Metrologic, Codem, Zeiss Calypso, right? So a lot of these, the major metrology platforms have this capability of importing QIF. So now we're going to extend the digital thread into my metrology platform. So starting off inside of NVIDIA, now this is just a contrived part, but I'm going to massage my bill of characteristics, import my 2D specifications, and once I have that, I'm going to import this into Polyworks Inspector. And it's going to import my geometry, the PMI, my characterization, and all of those measurement features. And you can see all the measurement features as they're displayed here, and all of the PMI that are controlling or that I need to comply with on those specific measurement objects. All right. I can also see all of the PMI across the presentation states to ensure that it imported properly. And inside of Polyworks Inspector, they call these control views. Right? So I can see all the data and how it's organized by each presentation state as I look back at my native CAD to ensure that it imported properly. Right? So now I have my bill of characteristics inside my metrology software. I'm going to perform my measurement planning and inspection. At the same time, I can generate first article inspection reports. There are multiple methods of generating these reports. One is using NVIDIA and using very elaborate Excel files. But we can also upload and export our QIF, our bill of characteristics, and upload that directly to NetInspect. And this is a collaborative environment. So directly within NVIDIA, I have a publish button to NetInspect. So once I've massaged my bill of characteristics, I've injected my 2D specifications with my 3D, I can upload this into NetInspect where I've predetermined first article inspection reports and templates, and I can send this data downstream to my supply chain or even within my own internal manufacturing facilities to perform first article inspection. And next, we want to visualize these results. So let's bring it all back together using QIF. So we want to look at the as manufactured, the as inspected, back to the as designed. And I have a couple of different workflows. This one is bringing the data back from NetInspect. So Polyworks Inspector, right, the metrologist has uploaded this data into NetInspect for first article inspection, and I'm going to bring that data back into NVIDIA to visualize these results. So just as easy as it was to publish this information, I'm now going to import the data. I'm going to log into NetInspect, and I'm going to pull these results back in. You can see that it pulled in a single part in all of its reported values. But if I wanted to do a 30-piece capability study, I can certainly do that, and I can bring in as much data as I desire to get some pretty trend charts. All right, so now I can visualize. Videos are so fast. I can visualize that data directly back to the nominal, right? Looking at each individual requirement within my bill of characteristics. Right? It's really, really powerful. The other method I wanted to shed light on, and this is more of a manual method. We'll call it the data sidecar or the poor man's QIF. I can generate an Excel file up front of my bill of characteristics. I can send that Excel file to my downstream metrology, and then they can backfeed the results into that Excel file, and I can bring it back into NVIDIA the same way that I imported data from NetInspect. It's okay. We have to, in some cases, we need to take baby steps. All right, so in this one, we're going to, very same workflow, is we're going to now import an Excel file that we got back from Polyworks Inspector, and I'm now visualizing these results the same way, mapping that data back to each characteristic to then understand and complete my disposition as needed. All right, so there was two different workflows there. So if you want to know more about how QIF can improve data interoperability, last year, Belkin, we wrote a blog about deep diving into QIF. It does talk more about what Daniel Campbell was talking about this morning, and then it goes further into these specific workflows. Okay, so you can scan the QR code. These slides will be available to you, but many of you are already taking pictures, so that's fine. So wrapping things up. I don't know how I'm doing on time, but that's okay. So how do we start, right? Starting your transformational journey around model-based characteristics, right? And some foundational elements. And the first one is shifting your characterization left in the process, right? Traditionally, this is being performed downstream in the producer domain or maybe in quality. And this is done manually, time-consuming, error-prone. We want to shift this left in the process, up front in engineering. I highlighted a couple of different methods of doing that by characterizing your data within your native CAD, or even assigning characteristics at QIF export. Okay, so shifting your characterization left in the process is extremely important. Now you have persistent IDs across your life cycle. We want to author a complete bill of characteristics. That doesn't include just the characterization from your model-based definition. We also need to include 2D specifications. And when you think about a complete bill of characteristics, what's the percentage of characteristics that actually comes from your model-based definition? It's 60%? Yeah, so I mean, we need to account for the other 40. And in some cases, it might be the opposite, where 40% comes from your model-based definition, and that 60% comes from your 2D specifications. Okay, so we need to focus on generating that complete bill of characteristics downstream. We also need to rally and leverage industry standards. I talked a little bit about how authoring characteristics automatically or leveraging a QIF strategy is reliant, thank you, on, see now I broke my train of thought with my 10-minute warning. So authoring your product definition up front, it needs to be a machine-readable strategy. So leveraging standards like ASME Y14.5, 41, 47, but also rallying around the new model-based characteristics standard that's emerging, and even the QIF standard. Okay, so leveraging industry standards is important to drive that automation and to ensure a much better time with interoperability. And then work with your trusted subject matter experts in the field. Right, so Belkin is here, we have Action Engineering is here. We also have a lot of working groups in the industry within standards organizations within the DMSC. Become a member within the DMSC, right? And also there's groups on LinkedIn like the MBD, MBE Nerd Herd. You guys should all join that, right? But work with trusted subject matter experts.